Hello again, it's Matthew from Matthew North Music, and these weird noises you're hearing are coming from my modular synthesizer that I've been building over the last few months. And I've got some new bits here. We've got this panel here and we've got this panel here, and in this video I'm going to show you how I built them and what they sound like. So we're going to rewind about 3 weeks to when I decided to build some of this. This is one of my ongoing projects. This is the Cosmo format analog synthesizer that I'm gradually building. I've built a voltage controlled oscillator, a filter, and then using the Look Mum No Computer panels and circuit boards, I've built a ADSR, a VCA mixer, and a drum machine. Now, the voltage controlled oscillator here worked okay, and I built it all on strip board. This is the strip board layout that I did, and it all works okay, and I'm pretty pleased with it. However, I want to build another oscillator, and also I want to try and save a bit of space on the build on the front by having some other things mounted on the same panels. And that's where this comes in. This is a printed circuit board made by somebody called Sam Vella, and this is for a Curtis CEM3340 voltage controlled oscillator. And everything pretty much fits on the board. Power comes in here, we have our main chip here, we have an op amp there, a TLO72, and then we've got our outputs on the bottom here, and all we need to do is to populate the board with the required components, and this should make a nice little sawtooth and triangular waveform oscillator. It doesn't have anything extra in there to make a sine wave or a square wave, but I want to have this as an addition to on my synth build, so we're going to have a go at building this. Well, I've got my Curtis chip here, and I've got my little bag of TLO72s and some sockets for them. There's our board. But the first thing I always do is I put in the resistors first. So I've got my big box of resistors that I have to say I've pretty much got every value I need now for most of my projects, which is really good. So we're going to go through. I've got a printout of the bill of materials that I did on a piece of paper, but that was the last number, so it should be okay. And I'll start populating with the smaller parts first, so resistors, capacitors, and then I will pop in the chip holders, and then all I've really got to do is connect it up and test it, because there really is hardly anything to this. So far so good then. I've mounted all the components and I've put the IC sockets in. I didn't have a vertical style trim pot there, so I've got a horizontal one, and I've just literally put a piece of wire across there. I mean, it's not that elegant, but it's functional. All I've got to do now is wire up a couple of jack sockets just for the control voltage in one of the outputs, just to test, as well as wiring in a pot to here for the coarse tuning level. And I'll put some connectors on there just for the power, and then we'll give it a quick test. Right, on my little bench here, I've got my little bench amplifier that I like to use to test things with. And we shall plug that into one of our outputs there, and we've also got a control voltage input, which if it makes a noise, I will then plug something in just to do that side of things. Now I'm just going to check the polarity of my power, and yeah, the stripe is the negative, so it goes like this. So if I pop this into here like so, we should get some noise. And we got absolutely nothing. Nothing at all. The problem I had was that the little pot here that I used to fine tune it was too far off the scale, so it was going to a very, very high frequency. And also, as I learnt with the Look Mum No Computer chip, I had to connect the left hand side of the pot to ground. If I do that by holding it onto the jack, you can hear it. So that's basically what the problem was. So I'm going to ground that end, and this will basically be almost identical to the oscillator that I've already got in my modular, because I did actually swap the chips over as well just to make sure they were working, and they were. So it does work. That's the base thing. If I unplug the control voltage, then we've just got a basic control panel. So yeah, all works. All works. Good, 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 good. Right, the next thing I want to build is a low frequency oscillator. Well, this is the LFO that I want to build. Now, it's very simple. It's just got, you know, it's got a switch, it's got a pot, it's got one IC, got power coming in here, 2 capacitors and a few resistors, so it shouldn't take me long. Now, the idea to build an LFO is, you know, it's what you use to modulate your sound that you've got, so if you want to make it wobble and stuff. And this looks pretty simple to me, and what I also like about it is the fact that it's all on strip board. I found this on the internet. You can find these diagrams anywhere, and there's various sites that have them, but the best sites to go for are the ones that list that they've been confirmed and the circuits work, and you know, and all the rest of it. So yeah, this is what I'm going to build. So the first thing I'm going to do is find some Vera board, and I'm going to mark out where I need to cut the traces, where the squares are here, and then I will put in the link up wires here, 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 and here, and then I'll put in the resistors, I'll put in the capacitors, and I'll pop in the IC socket, and then there's a LED there, and we'll see what happens. Now, it's often been suggested that actually if you have your board and you use a Sharpie marker, this is pretty handy for marking out where you need to make your holes and where you want to put your wires. So with that in mind, this is going to be the bottom edge here, and I'm going to work everything from the bottom up, because we're actually one component, one line extra. So I'm going to work from kind of this end onwards. So we need to get rid of these 4 here, and then we go up, miss a row, another row, and then there's a gap there. So we want this one there, that one there, and then we go across 1, 2, and up, one there, one there. So we need holes in all of those places, and then we need to count up to the top. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's 18 and 19. So it's 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's these here. Now I think the only reason we're making holes here and here is because that's where you put in some screw holes to mount it to the chassis. So that's really handy. Right, next thing I'm going to do is hook up all the linking wires and then start laying some components in. So I'm going to get on with that now. Right, well, I still consider this to be in a slightly prototyping mode, but anyway, there's our circuit board complete. Here's a little switch. Now, this switch switches between these 2 capacitors, which set the range of frequency for the low frequency oscillator. And here is our pot that we will use to change the frequency. Now, this LED is connected to the square wave output, and the idea is, hopefully, that when we add some power, that light should flash. So we've got our power here. I'm just going to double check that I've got the polarity the right way around, and I have. I did forget, I should have actually put a box, you know, a reciprocal connector to this on here rather than just pins, but I didn't. Anyway, let's just pop this on, and we can see a little LED. If I turn this light off, there we go. You should be able to see our LED flashing. If I turn this up, or down rather, it's going slow, and then it's going faster. And if I flip the switch, There we go. Up, off. If I turn this up a bit. That's going on and off. So that worked first time, as the other oscillator did, although I didn't realise that at the time. No, it's brilliant. I'm really happy with this. So this is the Roland System 100M LFO. And yeah, really pleased with that, really pleased indeed. So this is the second part of the module that I'm going to build. This is actually going to be my next project. Now you're probably looking at that thinking, what is it? Well, it's actually a clone of the kick drum of a TR-808, the famous Roland drum machine. And I printed all of this off the website of a guy called Eddie Bergman, based in the Netherlands. And I printed everything out because sometimes if you just get a printout, you can just follow things through much more easily. And what's really nice about the way he's done his circuits is that you've got your bill of materials, so you can tick things off as and when you fit them. But what I really like as well, he does a diagram with just the cut marks and the wire links, so you can actually get that done first. And it's just slightly easier to look at than if you look at the sort of standard diagram with everything on, because you know it's quite possible to miss the odd thing out, like you've got some cuts under there and you never know whether there's one under there or not or whatever. So certainly it's done really well. So I'm going to build this one next, and just because I can, really, just because it looks like a bit of fun. The finished thing I'll then mount on a Cosmo sized piece of metal. And if we go further through on his diagrams, as you can see, I'm really well organised with this. I think it's this one here. Yeah, this one shows you everything that it's got. And we've got a decay control, a pitch control, a tone control, and a level control. And you just have a trigger in, which would be, you know, a gate out the BeatStep Pro, or even anything basically that chucks out 5 volts, and then you get your audio output the other side. So I'm looking forward to building this. This looks relatively simple. This is something you might find useful in your build if you're going to build anything like this, and that's that I've got some of the wires placed in, but I haven't actually soldered them in yet. I've literally just pushed them in and bent the ends, because that way I can then cross-reference against the diagram just to make sure I have got them all in the right place, because I have done these in the past where I've put the odd wire in the wrong hole. I mean, so far I've double checked all of these and they've tallied up okay, so I've just got another 4 or 5 more to put in, and then I can solder them all in place. And as you can see, I've already made all my holes for the track cuts as well. Well, that's all the link wires done, and I don't think I made too bad a job of it, to be fair. And if you turn it over, do that. It's always a good idea to use something like a magnifying glass just to go over all of the joints, just to make sure that you haven't made any mistakes with any of it. I've got most of the components in now, but I don't know if you can see very well. Some of them don't quite fit, and they're sort of at a funny shape. And also you can see here, it almost looks like I've got a network of resistors. I'm just making up a value because I needed 8.2k and I didn't have one, so I've just soldered these 3 resistors together. However, what I'll do is I'll order some 8.2ks and I'll replace it. So it's not the tidiest circuit in the world, but everything's on the board now. So the next thing to do is to hook up all the sockets and pots, of which there's 4 pots I think and 2 sockets, and then we'll plug it in and see if it works. Okay, this is a bit of a Heath Robinson setup, but I've finished the unit and I've just got this plugged into a little amp, and I'm going to take a drum output of my BeatStep Pro, and I'm going to go to drum mode, and it's drum number 1, which I think is here. That's drum number 1, isn't it? So I'm going to stick a pattern on there and start playing it. So I think that's working, and leave that turned down for a second. I'm going to pop the power into it. The only thing I haven't done is wired in the LED because I just haven't got around to do it. There we go. It's working. The clipper's working. Yeah, you can't hear the tone change too easily. You can have to turn that up. And this is the... So yeah, it's working. D. Now, I don't know about many of you, but I am absolutely hopeless when it comes to metalwork. And so I was really pleased to find these panels on Amazon that basically are the Cosmo size. They're 20 centimeters by 10 centimeters. And on the back, they've got like a pull-off protection that I can actually use to mark things out. And for £6 each, I think these are really good because I can mark out, as I've made a rough mark on here, where I'm going to put all my pots and sockets and things, where I'm going to mount things. And then drill all the holes, and it's a perfectly shaped piece of metal. So I've got two of these. This one's going to be the one for the oscillators. I'm still waiting for my metal standoffs, so I'm not going to drill this one yet, but I have got a couple of standoffs knocking around in my box, and I'm going to use that for the kick drum module. So I'm going to mark that out, drill that out, and finish putting that back together. Okay, well, everything is now drilled. These funny 3 holes here, these are the ones that are holding the circuit board onto the panel. We've got our 2 output jacks there. We've got a little switch there that's going to be for the clipping. Got an LED there, and our 4 controls here. And now I'm going to spray paint this black, and once it's dry, I'll put everything on the panel. Well, it's a nice sunny afternoon today, and this panel here is the other panel I've made. This is the one that's going to have the 3 different sources. We've got the main oscillator there, we'll have our LFO here, we'll have our noise here. Now, I haven't drilled any holes for mounting the other 2 Vera boards because I might actually just glue them in with hot glue gun. I'm not sure yet, so I haven't drilled any holes, but all the holes for all the sockets and everything are done. And this is my favourite bit of the job. It really doesn't take long to hammerite a panel, and I'm going to leave that out in the sun to dry off, and hopefully by tomorrow it'll have hardened enough that I can mount everything onto the panel and then hopefully give you all a little sound sample. One of the many good things about a sunny day is that the paint dried really quickly, and this is the finished TR-808 kick drum, and as you can see, I'll probably just cable tie these wires together because they're a bit long. Or I might even just shorten them a bit and resolder them, but you know, it works. And yeah, we'll straighten that capacitor. Yep, that's it. I had some plastic standoffs knocking around and I just used some long bolts. And we've made our kick drum. Unfortunately, I had a little accident. There you go, as you can see, a nice selection of bolts and nuts and washers all tipped over onto the floor. Oh well, never mind. Okay, I'm going to start with a kick drum here, and I've just made a quick sequence, and I'm just going to play it. Now on here we've got various controls. This is the pitch control. So you can change the pitch of the drum. We've got a tone control here. You sort of notice it a bit better when the tone's right up. This is just our volume control. And you'll notice the pots are actually all wired back to front. That was my fault, but hey, it works. And here we've got a decay sound. So it can be very short or very long. In fact, if you turn the pitch up, you can kind of hear how it does its thing there. So I tend to have a lower pitch, lower decay, and it sounds a really good, nice, solid kick drum. Now, the next thing I'm going to look at is the noise generator. And the thing with the noise generator is this. If we patch it, so we've got our We have our noise coming out of, and this is the great thing with modular synths, is that everything's based on on various jacks and inputs. So I'm going to plug this in now. I actually need some more gain because this this noise generator actually isn't that loud. So I've got this box here, which is basically a preamp that I built for microphones. And it's got transformers inside. It's very low noise, but it does work really well. So I'll just rob this cable here, and I'll put that in there to get our noise. And if I now follow this through, so I've got the noise going into this cable, going into this input of the VCA. It's coming out the VCA onto this channel here. There we go, got some noise there. Let me turn my LFO off. So yeah, that's basically noise. And I'm going to trigger this noise from another output of the BeatStep Pro. So if I unplug this and stick this into, say, channel 2, and I then flip that switch there, and every time I hit, so I hit this, and it gives me noise. Now, why would I do that? Well, because you can actually work with this and shape it, and I'm actually going to use the ADSR as well. So I'm actually going to take that out of track 2 into the ADSR for our control voltage, and then the output of the ADSR is going to go into here, and then that way I can shape the sound. See here, there, I just press it and it sort of decays off. Now, when we're playing our kick drum, I'm just going to play it to you again so you remember what it sounds like. If I add some noise onto the second beat here, and then I play it, we effectively get a snare drum. And if I alter the, and I can actually EQ it a little bit, and that is how a snare drum was made in the old days of analog drum machines. You just added noise to the kick drum. In fact, I could even change the pitch of the kick drum. So it almost sounds like a tom-tom now, with a sort of industrial sounding snare drum. But yeah, that's how a snare drum sound was created. And in fact, if we look at the 20 drums here, that's exactly how it's done there as well. Now, the other thing you can do with noise is it can be quite effective as a sort of sound effect if you pop it through a phaser. And I actually first saw this done by Jean-Michel Jarre on a documentary. I think it was when he remade Oxygen and did his live in your living room thing. So I'm just going to plug the noise generator into the phaser, and then I'm going to come out of the phaser into the mixer. So I'll just pull that jack out for now. And if I pop that in and turn it up, there's our rather shashy, horrible noise. But then if I put the phaser on, I'll slow it down a bit, you get that nice sort of windy sound effect, you know, very kind of Jean-Michel Jarre Oxygen sort of sound with that. So, you know, noise can be a useful tool in the arsenal of analog effects. I don't know how this film is coming across to you, the viewer watching this, but I've kind of made this whole thing all over the place. But I'm just going to do some little tests with the LFO and the oscillator and various configurations. So at the moment, nothing's plugged in, and here's our oscillator. And if I turn the filter, you get that, and you can change the pitch. We've got some resonance going on the filter. If I turn the resonance off, it's just a basic, but the resonance really adds something to the So what I'm going to do now is I'm going to take the output of the LFO, and I'm going to stick it into the control voltage of the resonance on the filter. And now if I press the button, you can see there how it's going. And if I go to a square wave, it's almost like an on-off switch. You can turn it up. Again, you see it's flashing there. So it's quite powerful with the filter. Now I'm going to use the LFO in conjunction with the pulse width modulation of the oscillator. So here's our... So that's a basic oscillator sound, and if I put the LFO into that, whack that a bit. Now if I switch it to the square wave, it's got like a definite sort of pitch change, if you like. So it's better with the sawtooth. Anyway, hope you enjoyed this video. If you did, as always, please like and subscribe, and I'll see you on the next one.